And we are now moving to Module 6. We've been working on equations in the first 5 modules, and remember, what makes something in algebra an equation? It's that equal symbol, because it balances. The left side and the right side have to be equal, balanced. So now in Module 6, we're going to change up that symbol. Instead of working with equations, we're going to be working with inequalities. And when you hear the word inequality, you have to think of less than or greater than. So let's go to our class notes. So if you look, the first thing we have is our definition. An inequality is a mathematical statement that contains one of these 4 symbols: less than or equal to, greater than or equal to, less than, or greater than. Okay, there's a big difference between working with an inequality than working with an equation. As we've seen in the past 5 modules, when you solve an equation, you get a solution. And if it's a linear equation, we get one solution, such as x equals 5. We also saw if it's quadratic equation, we can get 2 solutions. We saw if it was a polynomial equation of degree 3, we would have 3 solutions. If it was a polynomial equation of degree 4, we would have 4 solutions. So with equations, with equal signs, you get a specific number of solutions. The difference is now we're going to be working with inequalities. So if I say the inequality x is greater than 5, I'm asking you how many numbers in our number system are greater than 5? Well, think about that. Can you list on a piece of paper every number greater than 5? No, you cannot, because there's not just one number greater than 5 or 2 numbers or 3 numbers. There's an infinite set of numbers. Just like Buzz Lightyear would say, there's an infinity of numbers greater than 5. So with an inequality, our biggest difference is there's going to be an infinite number of solutions. And because we can't list all those numbers bigger than 5, we're going to have to show this answer, this solution, by working on a number line. So what we're going to do today is we're going to have to go back and recall from algebra, how do you set up a number line and draw the solutions? So let's go to the whiteboard, please. Okay, guys and gals, if you look here, I have 2 inequality statements. This is x is less than 5. So again, if I ask you how many numbers are less than 5, you could be here forever. 4, 3, 2, 1, 0. There are fractions that are less than 5. There are decimal values that are less than 5. So because we can't list all those numbers that are less than 5, we're going to show that on a number line. So remember, 0 is your neutral number on a number line. So 5 is to the right. And any number less than 5 would be going to the left. Now watch this. You're probably thinking, where does this inequality symbol come from? It comes from the arrowheads of the number line. This inequality symbol is pointing to the left. Just like here, the arrow is pointing to the left. So you should never wonder what directions are the numbers less than 5. If you're at 5, that's pointing to the left. And you will physically on your number line shade all the numbers less than 5. Now don't stop at 0 because there are negative numbers that are less than 5. So you have to shade your number line all the way down to the end. Now when we say x is less than 5, does that include the number 5? If you are less than 5, can you be the number 5? No, you cannot. So this is where the change is going to be between algebra and college algebra. Back in good old algebra, to show that 5 was not part of the answer, you would put an open circle, which means 5 is not part of it. It's not included. Well, we don't use open circles in a college algebra. We have a new symbol, and this is what you're going to have to get used to using. To show that 5 is not part of the solution, you're going to use a parentheses. Now, you can write a parentheses either direction. It matters which one you put. You're going to put a parentheses on 5 that faces the shading. So kind of you can think back to the 80s to the game Pac-Man. Your symbol parentheses wants to eat the shading. So we're not going to use this one because it's not facing the shading. We're going to use this parentheses. This parentheses takes the place of that open circle. And this says 5 is not part of the answer. The shading means these are all the numbers less than 5. Okay, let's go to this inequality. This is read x is greater than or equal to 5. So again, can you list me every number that's greater than or equal to -5? You can't. So again, with inequalities, you're going to have to draw a number line. So we're going to go to 5 again. But now it's saying greater than 5. Greater than, that arrow is pointing to the right. Just like the arrow on the number line is pointing to the right. So you're talking about all the numbers that are greater than 5. So we're going to shade all the numbers greater than 5. And you go all the way down to the end of your number line. Don't stop. It says here x is equal to 5. That means x can be the number 5. 5 is part of the solution. So think back. In good old Algebra 1, to show that 5 was part of the solution, you put a closed circle. Remember that? Well, we don't use that anymore in college math. We get a little bit fancier. So no longer are you going to see a closed circle on your number line. What we're going to use in place of the closed circle is a bracket. Square bracket. And again, we're not going to use both. Just like a Pac-Man, we're going to face that bracket towards the shading, like it's eating it. So we're going to put this bracket on 5. And that tells me all the numbers are bigger than 5 and also the number 5. So the biggest difference right now with inequalities is drawing the number lines. No more opened and closed circles. We will use parentheses when you do not equal the number. We will use a square bracket when you do equal. Parentheses means not part of the solution. Bracket means is part of the solution. Okay? The second thing that's going to change in college algebra is the way you write your answer. Let's go to the notes for a minute. If you look here, it says in college algebra, we can write our answer in 2 different types of notation. Now, the word notation means how to write something. Okay? When you write your name in print and script, that's 2 different notations. In algebra, to write an inequality answer, you can either write it in what we call interval notation or set builder notation. Okay? And that's what we're going to talk about. What are the 2 different notations? So, you're used to writing an answer in set builder notation. Back in Algebra 1, we use set builder notation. Set builder notation is when you actually write the statement with the inequality symbol. So every time you write an answer in set builder notation, you will see the less than or greater than symbol. If you're asked to write the answer in interval notation, you will not use the inequality symbol. You will use parentheses and brackets. And I'm going to explain to you how to do this. So let's go back to the whiteboard. Okay, guys. If you look back up here, once you get your number line drawn, then on your homework, they're either going to ask the answer to be written in set builder or interval. Set builder notation is the statement with the inequality symbol. So if you look very closely, this is set builder notation. When I read x is less than 5, that's what we call set builder notation. I see the inequality symbol. Now, back in algebra, you cheated. You just wrote for the answer x is less than 5. Well, that's not acceptable. Set builder notation has to be written a specific way. First of all, anytime you hear the word set, a set is a collection of items. And those items need to be grouped together. And the symbol for set is a brace. Just like the braces of your teeth hold your teeth together, braces hold information in math. So every time you write the answer in set builder notation, it will start off with these squigglies, which their official name are braces. Then you'll see something fancy in front. It will have the letter X and this line. And that line is read as the word such that. Now, I know that's crazy. It looks weird, but it's formality. Think about it in real life. Have any of you ever read a legal document written by a lawyer? Well, it takes them a paragraph to say one thing. They have to write everything in a special mumbo-jumbo kind of way. Well, in math, the official way to write an answer in set builder notation is to first of all put it in braces and always start out with X such that. And then after that, you'll put your statement. So if we go over here to B and I say write this in set builder notation, what symbol are we going to use? Good. We're going to use braces. It's always in set builder going to start off with what way? X such that. And then after this goes your statement. Where is your inequality statement? Where's your statement with the inequality symbol? It's right here. So you'd write X is greater than or equal to 5. So it's not hard to write set builder notation. It's already given to you. You just have to put it in the braces and write the X such that so it looks proper. Okay, the new way to write an answer, a solution, is in interval notation. Now, believe it or not, you have no work to do here. You've already done it. You will get interval notation by looking at the number line. So interval notation always comes from the number line. So when we're working with inequalities, even if the homework doesn't say draw a number line, you need to draw a number line because that's the only way you're going to get to be able to write the answer in what we call interval notation. When you write an answer in interval notation, you're looking at the number line and you're looking for two things: where the shading starts, then you're going to put a comma, and where the shading ends. Now, it's very important you read a number line correctly. It goes back to English class. If I write this word on the board, what do you all say that word is? Oh, I don't think you can see that. Let me bring it down. There it is. If I write that word on the board, what word is that? Well, you would read dog, D-O-G, because in our language we read left to right. If you read that right to left, it would say God. So it's very important that in our English language, if we have to read a word left to right to say it correctly, then we have to read a number line correctly in math. And to read a number line correctly, you read it left to right. Smaller, bigger. So when we write an answer in interval notation, the first thing we want to know is where the shading starts. So if we look at this number line, here's where the shading starts. Well, is that on an actual number? No, it's not. In fact, when you say you're less than 5, you can go on forever and ever and ever. Well, what's that concept if you go on forever and ever and ever? Very good. It's called infinity. Now, in math, believe it or not, we have two types of infinity. If you move to the left, the infinity would be negative, because that's where our negative numbers are, on the left of the number line. If you're moving to the right all the way, your infinity would be positive. So if I'm just trying to explain where the shading starts, and it starts at the end here, which I can't put a number on it, I would say the shading starts at negative infinity. Then I'd put a comma, and I'd ask you where the shading ends. So follow your hand, and the shading ends here, and it ends at 5. That seems pretty simple, right? All you're doing is looking at the number line and reading it left to right. Now you got to put symbols. Well, the 5's got the parentheses on it. We need a symbol on infinity, negative infinity. Now there is no symbol on this left side, so we got to think. When they say the answer is in interval notation, they either want you to use parentheses or brackets. Let's review what they mean. Brackets means 5 is part of the answer, and is means equals. You equal 5. Parentheses means you are not part of the answer. You are not equal. So let's think about this a minute. Do we put a parentheses or a bracket? Can you equal infinity? No, you can never equal infinity, because think about it. Infinity goes on forever and ever. So infinity will always get a parentheses. It can't get a bracket, because bracket means equals, and you can't equal an infinity. That isn't a number. It's a concept that means going on forever. So write yourself a note. When we write an answer in interval notation and it has an infinity, whether it's positive or negative, it always gets a parentheses. This, guys, means the same thing as this. This says I colored in all the numbers less than 5. This says I colored all the numbers in on the left, negative infinity, and I colored up to 5. So that's the hardest part about this whole chapter, is understanding what they want the answer in, what notation. Let's try again. Look at this picture. We've already written it in set builder. Now we want it in interval. To get interval notation, where are you going to look? Very good, the number line. You're going to first look where the shading starts. So remember, you always start on the left. Is there any shading here? No, 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 no. There's the shading. So it starts at the number 5. And 5's got a bracket on it. Then you put a comma, and you tell me where the shading ends. Well, does the shading end? Well, you could say it ends there, but is there an end to this number line? No, the arrow indicates this number line goes on forever and ever. Because we're going on forever and ever to the right, that's not going to be negative infinity, that's going to be positive infinity. And what symbol do we always put on infinity? Good, a parenthesis. So the hardest part about working with inequalities is not the actual work we're about to do, it's how to write the answer. You've got to get used to reading and seeing, do they want the answer in set builder with the inequality symbol, or do they want it in interval notation where you're looking at the number line? Okay, let's go back to the notes for a minute. Okay, so now that we discussed this, let's talk about solving. We're actually going to solve some inequalities, just like we solved equations. The great thing about today is the work is not anything new. If you can solve an equation, get x by itself, you can solve an inequality by getting x by itself, by the same rules. However, there is an exception, and that's what your notes say. Solving an inequality is just like solving an equation, with one exception. When you multiply or divide both sides of an inequality by a negative number, you must reverse the inequality symbol. So that's what we're going to work on now. We're going to work on how do you solve an inequality. Let's go back to the whiteboard. Okay, so let's just see the difference. In your notes, you have negative 2x equals 6, and you have negative 2x is greater than 6. First of all, what do we call this? It has an equal sign, so this is called a what? Very good, it's called an equation. What kind of equation? Is it linear, quadratic, polynomial, rational, radical? Everything we've learned so far. It's obviously linear. It's x to the first power, so it has one solution. How do you solve this? You know to move the negative 2 by division. This is going to cancel. You're dividing the same number, and you get x equals negative 3. Now, when you write the answer, we've been writing it all along, all semester, just x equals negative 3. You can't write that answer in this new notation interval because it doesn't begin and end anywhere. This is the answer. If you drew a number line for an equation solution, you would go to negative 3 on the number line, and you just put a closed circle because that is the only answer. So when we write an answer for an equation, it's always in set builder. If you want to be fancy with it, you could write x such that x equals negative 3. But you can't write it in interval, because to write it in interval notation, you have to begin somewhere and end somewhere, and there has to be some shading. And obviously, we don't have that with an equation. If we come over here, this is not an equation. It has a greater than symbol. So this is an inequality. As soon as you know it's an inequality, you know there's an infinite amount of answers. To solve this inequality is the same way as solving the equation. We have to move the negative 2. So we would still do divide by negative 2. A negative divided by a negative cancels out and makes a positive. 6 divided by negative 2 is still negative 3. Here's the exception to the rule. When working with inequalities, if you physically divide by a negative number, you must reverse that symbol. And by I say reverse it, I mean flip it over like a flapjack. So instead of it being a greater than, it's going to become a less than. Now you're going to say, why do we do that? Because remember, if we're looking to get answers that are going to check in here. Just like we go back to this equation. If the solution is x equals negative 3, we could check that. Negative 2 times negative 3 would be 6. Is 6 equals 6? Yes, it checks. By reversing this inequality symbol, if we check this, it will work. Give me a number less than negative 3. Well, there's a ton of numbers less than negative 3. I'm going to pick negative 4. And if we check it, it will work. Negative 2 times negative 4 would be 8. Is 8 greater than 6? Sure it is. So that's the only thing you have to remember in this whole section of this chapter. When working with inequalities, if you divide by a negative number, you have to reverse the inequality symbol. Because it's an inequality, you must draw a number line. You cannot on paper list me every number less than negative 3. So we'll go to our number line. We'll go to negative 3. We're going to shade with inequalities. Less than is going to shade. It's pointing to the left. Now you got to put a symbol. No more open and closed. That's gone. It's either parentheses or brackets. If you say you're less than negative 3, are you the number negative 3? Do you see an equals there? No, you do not. So negative 3 is not part of our answer. So we're going to use parentheses to show it's not part of the answer. And just like a Pac-Man, it's got to face the shading. Now, when you're doing your inequality homework, they're going to say in the directions, either write it in set builder or interval. So you're going to have to read your directions. Set builder is always going to start out with the fancy braces. Braces hold things together. And it's going to start out with this X such that. Okay? Then behind this goes your inequality. When you're done solving, that's what goes in set builder. This statement, X is less than negative 3. To get interval, you're going to look at your number line. And what direction are you going to start at? Very good, the left. Where are we starting at on the left? We're starting at the very end, which is not a number. That's negative infinity. And how far are we shading? To negative 3. Negative 3's got a parentheses on it, which means it's not part of the answer. What symbol do we say goes on infinity always? Good, a parentheses, because you can't be part, that's not part of it. You can't equal infinity. And that's the only difference, guys, between solving equations and solving inequalities. It's not a lot of more work. It's just writing the answer correctly, drawing a number line. All right, I think I have another example to work with, you guys. So let's get my notes. Let's try another one. Okay, so now I have the inequality. 2 minus 3x is less than or equal to 5. First of all, it's an inequality because it has an inequality symbol. That automatically tells you we're going to have lots of answers. We're going to need to draw a number line, and that means our answer can be written in 2 different ways, set builder or interval. Secondly, we know this is linear because it's still x to the first power, so we're going to use our rules and get x by itself. So what are we going to move first? Good, we're going to subtract 2. That's going to cancel. We have negative 3x less than or equal to 3. Are we done solving? No. Now we're going to divide by negative 3, and this is when a bell should go off. Ding, 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 ding. Oh my, we're dividing an inequality by a negative. We have a special thing. We have to reverse that symbol. And 3 divided by negative 3 is negative 1. Is everybody okay with that? So that's the only exception to the rule. Now, because it's an inequality, you must draw a number line. We're going to negative 1. It says greater than or equal to. Which way are we going to shade greater than, guys? Very good. The arrow is pointing to the right. What symbol goes on negative 1? Do we put a parentheses or a bracket? Well, it says equals. Equals means it's part of the answer. The symbol we use for equals is bracket, and it's always got to face the shading. Now we got to write our answers. We either have set builder or interval, and you got to read. Sometimes they only want one of them. Sometimes they want both. Set builder is always going to start out with what symbol? Good, braces. Braces hold things together. Then we're going to be fancy and write x such that. Now behind x such that, what are you going to put? Very good. When you're done solving your inequality, this is your statement that goes in set builder. You were saying all the answers are greater than or equal to -1. What happens if I want the answer in interval? Well, now I'm going to go to the number line. So we always start on what side? The left. No shading, no shading, no shading. Here's where the shading starts. It starts at -1 and we put a bracket because that's what -1 has. Comma. How far does the shading end? Well, it doesn't end. It's going all the way to the end. It's going to the right, so that's positive infinity. What does positive infinity always get? Very good at parentheses. You cannot put a bracket on infinity because you cannot equal infinity. And brackets mean equals. That's all there is to it. Okay, let's try another one. Okay, we have 3x plus 1 is greater than 3x plus 2. All right, so in your notes, this is our next inequality. So again, it's linear, it's x to the first power, it's x to the first power. We're back to the first day of class in section module 1.1. What do we do here? We're going to distribute first. We're going to get 3x plus 3. Miss Black's rule of thumb is when you're solving a linear, whether it's an equation or inequality, variables always move to the left. So I'm going to subtract 3x. What happens when you subtract 3x from 3x? Very good, it cancels out, it leaves you 3. Uh-oh. What happens over here when you subtract 3x and 3x? It cancels out, it leaves you 2. Now, we've seen this before. This was module 1b. Sometimes when you solve, like Little Bo Peep lost her sheep, you lost your variable. And when you lose your variable, you either have a true or false statement. What statement is this, ladies and gentlemen? 3 greater than 2. Very good. That's a true statement. So just like we did in module 1b, a true statement means there isn't one answer for x, there isn't 2 answers, 3 answers, there aren't 10 answers, there aren't 20 answers, there are all the answers. This statement means if I look at the number line, I'm going to color in all of it. Every number on the number line works. And I'll prove it to you. Pick any number you want on the number line. Let's pick 0. If I put 0 here, it will work. 0 plus 1 is 1. 3 times 1 is 3. So the left side's a 3. If I put 0 here, 3 times 0 is 0. 0 plus 2 is 2. So the right side is 2. Is 3 greater than 2? Sure it is. But I don't have to pick 0. I can pick any number I want, and it will make this always balance. So when you get a true statement with inequalities, it's just like a true statement with equations. All numbers work. Now, how do you write that? Now, remember, we got 2 different ways to write this because we're in inequality land. We're doing set builder and interval. Interval is actually easier because if you look at the number line, where does the shading start? It starts all the way to the left, which is negative infinity. And how far does the shading go? It goes all the way to the right, which is positive infinity. And that's what this means. When you write the answer goes from negative infinity to positive infinity, you're saying I'm colored in the whole number line. Any number will work. To write that in set builder, you'll still use the fancy braces and the x such that. But the way you write this is you can't use an inequality symbol because you're not bigger than a certain number, you're not less than a certain number, you're all the numbers. So you'll write this as x is all real numbers. Okay, that's the only way you can write it, as words. Now, if you want to be fancy, we could write this with some symbols. So if I put the braces, x such that x, instead of writing in words, x is all real numbers, I could write x, use this Greek letter that means the word element, and the abbreviation for real numbers in math is this capital R. And that says x such that x is an element of the reals. That's saying x is any number that's real. And remember, that's what you call all the numbers on the number line, real. All righty, I think we have one more in this section, so let's look at our last inequality here. It is x plus 1 less than or equal to x minus 1. So it is an inequality. You know there's going to be more than one answer. It's linear. It's still x to the first power. So we still solve it the same way. We move our variables to the left. But when we move our variable to the left, x minus x cancels, that leaves 1. X minus x cancels, that leaves -1. So again, sometimes when you solve an inequality, just like we did with equations, you're going to lose your variable. If you lose your variable, your statement's either going to be true or false. Which one is this? Is 1 less than or equal to -1? Well, that's obviously false. So think back to Module 1B. What does it mean when you get a contradiction? When you get a statement that's false? What is your solution? Very good. When you get a false statement, it always means there is no solution. No solution means there's no number you could pick to make this balance. I'll prove it to you. Pick a number. Let's pick 6. 6 plus 1 is 7. 6 minus 1 is 5. Is 7 less than or equal to 5? No way. So, and that's what you mean by no solution. No solution means there's no number you can pick on the number line that will make this balance. Now, how do you draw a picture of that? Well, there's your picture, guys. You draw a number line and you leave it blank. You don't color anything in. And if they ask you to write this answer in set builder or interval, the great way is this. There's only one way to write no solution. It's the 0 with the slash. So we just reviewed information we already learned in Module 1, but now we're using it for inequalities. Okay, when you come back, we'll get to the next part of inequalities. Have a good day.